Tips and tricks number 10, matrices in row-reduced echelon form. All right, let's say we wanted to solve this system of equations using matrices. So what we want to do is first input the matrix, and there's now a quicker way of inputting that. If we use alpha zoom, the F3 menu, allows you to decide how to make a matrix. Make that bigger there. So you go up and you pick how many rows, which is 2. We want 3 columns, so press enter. Excuse me, and then go down to OK and press enter. And we're ready to go ahead and fill in the values. So I'm going to type in a 5, and you'll notice right away it says use a right arrow, not an enter. So I'll press the right arrow, type in -3 for the coefficient of y, right arrow, and then 29. And it says press right arrow, and yeah, it takes me right where I hoped it would. So 6, right arrow, 11, right arrow, and then -2. And I'll press enter and make sure our matrices are entered in correctly. And now I want to do row-reduced echelon form on this, and that's a matrix command. So I'm going to go ahead and press second X inverse to get the matrix. I want to go over to math, and these are in alphabetical order, so I think I'll press the up arrow and go up to letter B, row-reduced echelon form. So press enter, and press the up arrow twice to highlight the original matrix. Press enter and paste it down. And you don't have to put in the right parentheses, but in my class I prefer you do. Press enter, and it's telling me that 1x plus 0y's is this decimal, 0x plus 1y is this decimal, so this is x, this is y. It would be nice if those were fractions, and you can perform the fraction, convert to fraction on an entire matrix. So I'll go to alpha y equals, and number 4, when I press enter, says take the last answer, which is a matrix, and convert it to the other, which in this case are fractions. So x is 313 over 73 and y is -184 over 73. Those were probably the answers you were thinking when you first saw the system, I said facetiously. So while we're at it, I think I show you another way that we can do this. There's also an app called the PlySmlt2 app. So let's show you how that works as well. So again, this is app, press apps, PlySmlt2. And I want to do the second option, which is simultaneous equation solver. And I can go from a 2x2 up to a 10x10, which is crazy. But you'll notice I have words along the bottom here, and these words apply to the hotkeys that are along the top row there. So y equals is main, trace is help, and graph is next. So I'm going to press graph to go to the next screen. And the next screen is me typing in those coefficients. So I'm going to type in a 5, and this time I do press enter. And notice I can change the plus and minus, so I had a minus sign there, so I'm going to type in a minus. And then 3 y's, enter, and 29, enter. 6, enter, and a plus sign, enter. 11 y's, enter, and -2, enter. So there's my system there. Just to double check it. Okay. And now what I'm going to do is I want to solve, and solve is above the graph key, so I'm going to press graph, and surprise, surprise, there are my solutions again. Same ones that I had before that I got with row-reduced echelon form. So there's 2 ways of solving systems, and now you got to be aware that your students can do this. So again, don't let them use calculators unless you want to do applied problems. Now, one other thing I do want to show you is how to check this. Okay, I think it's important that you check these things. So I'm going to go off, I'm going to quit. So I'm going to go to main menu, which is y equals, and then I'm going to do number 6, which is quit this app. Anytime you use an app, you want to quit it before you move on. And I'll press clear. And so I'm going to store these numbers in for x and y. So again, I want a fraction template, 313 over 73, right arrow, and store that into x. And then negative fraction template, 184 over 73, right arrow to get out, and store that into alpha 1, which is y. Make sure I did that correctly. And now to check it, I'm just going to type in the expression on the left, 5x minus 3y, alpha y. And what the calculator do is going to take the current values of x and y, substitute them in, do the calculations, and for it to check, it better be 29. But it also has to work in the second equation, so 6x plus 11 alpha 1, which is y. Again, substitute those values, and it better come up -2. And so now I know for sure that this does, in fact, check. So I strongly encourage you to have your students do that just so that they see it, especially on numbers like this. How bizarre is that those are the only numbers in the entire universe that make both of these equations true at the same time?